Hi, this is Mrs. Slater, and today we're going to be doing 8.2, which is all about using quadratic equations in real-life examples. So first you need to understand the problem, then develop and carry out a plan, and then find the answer and check. And we will do 4 out of the 5 examples together, and then the last one you will be doing on your own. So number 1 begins with an open box. Now, before we can understand the problem, we need to understand what this open box is representing. So you can see right here, this open box has different sides. This particular one looks like it has square sides, and then some other ones you may have rectangular sides, which is definitely the case in our problem here. So if you would take this open box and lay it out flat, you would have a base, and then the sides would come out like this. And I know that is a horrible drawing, but I think you get the idea. So if you take each one of those flaps and fold them up, it creates an open boxed box. Okay, so now that you kind of have a more understanding of what an open box represents, what this is saying is that each box is going to start with a rectangular piece that's 10 centimeters by 20 centimeters, okay? And you're cutting a square from each corner. And then if you look closely, you can see that here is going to be the cutout for your rectangular box. And if you compare with the box we just talked about, see how it has 1, 2, 3, 4 flaps? So does this one. And here would be the base. Okay, so let's, I'm going to get rid of that. I just wanted you to understand the problem there. Now let's take what's given. So they're saying the area of the bottom of the box is 96. So this red box from each end of that corner is an area of 96 centimeters squared. And they want you to find the length of the sides of the squares that are cut from the corners, which would be this length. That is our unknown, what we do not know. Okay, so what we have to know before we even begin is what the area formula is for a rectangle. And you may recall that area equals length times width. Okay, so we already know that this red box right here is 96, so I'm going to replace A with 96. And then the length, if you look at the length of the side, it is going to be right here. So I'm going to highlight that a little bit more right here. And the whole entire shape or side is 10. They give you that in the beginning. So if the whole thing is 10 and we only want this area right here, 10 minus those unknown values will give us 10 minus 2x for this side. So the length I'm going to write down as 10 minus 2x. Now similarly, we can look on the right side or right or left side, and if the whole thing right here is 20, then we have again these little square boxes. Let me get a color you can see. Square boxes cut out from every corner. So the whole thing is 20 minus these two x's gives you the length of 20 minus 2x for the width. Now the length and the width are interchangeable just because it's multiplication. Okay, so now you can see it is lending itself to a quadratic equation, because if we multiply these two values together, we're going to get something squared. Okay, FOIL, and you end up with 200, and then the inside and outsides give you a negative 60x, and the last terms are a positive 4x squared. And after setting everything to 0, which is very important, you end up with 4x squared minus 60x plus 104. Okay, and if you ever have anything in common, you want to take out the GCF. That will make your factoring a lot easier. And if I take that 4 out and divide it by both sides, it will go away. Now I can only do that when I have something set equal to 0. Okay, so now we're left with a trinomial that we can factor. Factors of 26 that will give you 15 are 13 and 2. Both have to be negative, so then x, after using the zero product property, is going to be 13 and 2. Okay, now let's relate this back to our picture. And we have this rectangular piece, looks something like this. And the whole side from here to here was 10, and this was 20. So if I take the 13 for that little square piece, 13 for that square piece, it doesn't make sense in our problem because we cannot have more of a square than it is on the whole side. So that is considered extraneous. 2, on the other hand, fits very nicely in our problem. If I get rid of those 13s and replace it with a 2, that does make sense. So you have 10 minus the 2's on the end, you get a total of 6 for the width of that picture. And if you use that concept again for these two squares on the right side, 20 minus the 4, you get 16. So the question, since it's asking for what is the length and the size of the squares that are cut from the corners, the answer is going to be 2. 2 centimeters will be cut from each corner. Okay, and then the 6 and the 16 was just an added bonus. You did not have to find it according to the original problem, but that definitely is a way to check your answer because 16 times 6 does equal 96, which is supposed to be the area of the bottom. Okay, let's go on to the second one. Here we have a lawn of a large rectangular plot of grass. So you can see we have our lawn, and it has an area of 400 square feet. Okay, Elva walks around the plot and estimates that the perimeter, so from here all the way around, the perimeter is going to be 100 feet. How can we approximate the dimensions of the plot? Well, a quadratic is going to help us here. 2 equations we need to know. The area of a rectangle, length times width. The perimeter we also need to know is 2 times L plus 2W. So keep those in mind when you start seeing the information next. All right, so area. Area, length times width. We know it's 400, but we do not know the length and the width. L and W are what we're going to have to find. The perimeter being 2L plus 2W is going to be 100 equals 2L plus W. Okay, anytime you have something in common, we can divide everything by 2 here. 50 equals L plus W. And now it's going to be easier to use substitution. So we are going to solve for L or W, it doesn't matter. But by subtracting, now we have a value for L that we can plug in for the length in the area formula. So 400 equals 50 minus W times W. And you'll notice now we have a quadratic. So I'm going to distribute. I get 50W minus W squared. And go ahead and push pause and solve for X. So check your work with mine. At that first spot right here, when you are setting it equal to 0, I would take this negative W squared and move that to the left along with the 50W. Just makes it easier to factor. Factoring 10 and 40, and then you get the width could be 10 or 40 depending on how you look at the rectangle. But anyway, the way you plug 10 in, you're going to end up with L equals 40 anyway. Dimensions are going to be a 10 by 40. Okay, let's go on to the next example. Okay, we have a ladder and it is 2 feet longer than the height of a certain wall. So this would be the wall that I'm talking about. That's supposed to be about 2 feet. Okay, when the top of the ladder is placed against the top of the wall, the distance from the base of the ladder is exactly equal to the height of the wall. How high is the wall? So basically when that happens, you end up with a picture like this. You have a right triangle and you have the ladder is leaning against the wall, and they say that these two are exactly the same. So the height here is going to be the same as the base. So I'll call them both H, showing that they are equal to each other. This one is going to be the same height. So from here to here is the exact same height plus the 2 feet. So I can say that this is h plus 2. The latter is going to be h plus 2. Okay, now let's use the quadratic equation to help us out here. From Pythagorean theorem, it says that h squared plus h squared equals h plus 2 squared. And if you take like terms, put that together, and then h squared plus 4h plus 4, and then combine like terms, you end up with h squared minus 4h minus 4. Okay, now again, quadratic formula. Find factors of 4 that will give you 4, and you will come up with a dead end, because there is nothing you can do here. But we can use the quadratic formula to help us out, and it looks something like this, where we have h equals opposite b plus or minus square root of b squared minus 4ac all over 2a. Okay, and then where I'm getting those numbers are the leading coefficients in front. This is a 1, so a is going to be 1. This is negative 4, so b was negative 4. And c is the last term, which is negative 4 as well. Okay, and then simplifying the inside, you end up with 16 plus 16, which gives you 32, all over 2 times 1, which is 2. And if we simplify this, we want to use the simplified radical form here, and 16 does go into that, so I'm going to put 4 root 2. Okay, and then because every single one of these reduced by 2, I'm going to cancel a 2 out of each one of them. And it looks something like this. So you end up with h equaling 2 plus or minus 2 radical 2. But again, you want to take an answer and make it more realistic with the distance. So if I take 2 plus 2 radical 2, and then also 2 minus 2 radical 2, I come up with two answers of 4.828 and negative 0.828. Okay, you can't have a negative distance, so that's out, leaving you with 4.828 as the height of the wall. And this would be in feet. Yes, it will be in feet. Height of wall. Okay, so that concludes number 3. Let's go ahead and go to the runners on the next page. So we have 2 runners. Goofy is running at a right angle this direction, and we've got the other runner heading off in this direction, again forming a right angle. What the information given is going to show that Goofy is running at B rate, because we do not know what it is. The other runner is 4, I think it says 4 faster than Goofy, so I'm going to put 4, and then they say after 2 hours it's 40 kilometers. Now this describes distance, this is describing rate, and this is describing rate as well. And we cannot do Pythagorean theorem until we have all 3 of those the same. So if we multiply this by the time and this by the time, we'll be able to have all 3 of them distance, because we know that distance equals rate times time. Okay, and distance equals rate times time. So that's where we're going to use the 2 hours. Time would be 2 hours later. Time is going to be 2 hours later. Now let's look at the setup. So you can see that each side is reduced by 2 before we begin the Pythagorean theorem. So I would like you to finish the Pythagorean theorem for class and find out what B is. B is going to help you find the rate. Okay, and then that'll lead you into number 5 with the bicyclist. Please do that for class tomorrow as well as finishing up this problem number 4.